Chapter 15, Developing Fraction Operations. Grade 4, Adding and Subtracting of Fractions with like denominators and multiplication of fractions by whole numbers. In Grade 5, Developing Fluency with addition and subtraction of fractions and developing an understanding of multiplication of fractions and of division of fractions is a limited case. Grade 6, Complete Understanding of Dividing of Fractions. Solving real-world mathematical problems involving the 4 operations with rational numbers. Number 1, contextual problems for fractions help students develop their own method in building understanding. Number 2, area, length, and set models give different insights into fractions and a stronger conceptual understanding. Number 3, should 2.5 times 1/4 be more or less than 1? More than or less than 2? Estimation keeps the focus on the meaning of the numbers, and the operations encourage reflecting, thinking, and helps build the number sense with fractions. Students apply their prior knowledge, in this case whole number computation, to new knowledge. Using whole number knowledge can be support to learning. As an example, what does 2 times 3 mean? Follow it up with a question of what might 2 times 3.5 mean? The concept of each operations are the same, but the procedures are different. For contextual examples, consider real-life content of measuring something in inches, sewing, cutting, molding for a doorway, hanging a picture. 1 inch is 1 unit or 1 whole. Measuring includes halves, fourths, eighths, or sixteenths, or even 32nds of fractions that can be added mentally by considering the relationship between the size of the part, such as a half is 2/4, 2/4 is 4/8, 4/8 is 8/16. They're all the same. You could divide 8/16 down to 1/2 by dividing by 8, or you can multiply up from 2/4 to 8/16 by multiplying by 4. Circles are an effective visual for adding and subtracting fractions because they allow students to develop mental images of the size of the different pieces, such as fractions of circles. In the figure, it shows how students estimate first, including marking on a number line, and then expanding how they add the fraction using circles. Cuisinart rods are linear models. Suppose you had fractions of submarine sandwiches, which are linear. Students are suggested to use Cuisinart rods or fraction strips to model the problem. The first decision that they must do is what size is the whole. This decision is not required with circular models because the whole is established already. The whole must be the same for both fractions. In this case, the smallest rod that will work is the 6 rod, or the dark green strips in the example. Find a strip for the whole that allows for both fractions to be modeled. So in this case we have the whole, then we have 5/6 and a half. So we're going to slide the half over to the 5/6 to extend it. It's past the whole, which is 1/3 past. So it is 1 1/3. And B, we have the whole 5/6 minus a half. So now we're going to subtract 1/2 from 5/6, leaving 2/6 or 1/3. Use jumps on a ruler activity for activity 15-2. Provide a ruler, or you could use a number line. Have students use jumps on the ruler to add or subtract. So either add or a linear content, or ask students to create their own stories for each. These jumps encourage students to invite strategies without having to find common denominators. When sharing strategies, listen for students interacting, counting, and using fraction equivalency. In the first problem, students might use 1 as a benchmark, then count up 1/4 to get a whole, and then another 4th to have 1 1/4. Or they could use a half from the 3/4 to equal a whole, and then add up 1/4. One way to estimate is benchmark. Decide whether the fractions are closest to 0, half, or 1. Or to 3, 3.5, or 4. The closest whole number or half is between them for mixed numbers. After making the determination for each fraction, mentally add or subtract. Relative size of a fraction is another way to estimate. Decide how big the fraction is based on its units, the denominator, and apply this fraction to your computation. In the activity 15.3, over and under 1, tell students that they are going to estimate sums and difference of fractions. They are going to decide only whether the answer is more than 1 or less than 1, using estimation of addition or subtraction of fraction problems. You can project a problem for no more than 10 seconds, then hide it and remove it. Use less than 1 or more than 1 cards, or you can have students write down on a sheet of paper over or under, or thumbs up or thumbs down. Then discuss how students decide on their estimations. Over time, you can use activity 15.1 over or under 1. Can include tasks that are more challenging. You can use targets other than 1, half, 1/2, 2, 3, and so on. Choose fraction pairs in which the fractions are both less than 1 or both greater than 1. Estimate sums and differences to the nearest half. Ask students to create equations that are slightly less than or slightly more than 1. Make sure algorithms develop side by side with visuals and situations for students. With like denominators, it is important to make sure that students focus on the key idea. Units are the same, but they can be combined. 3/4 plus 2/4 is asking how many fourths. 3 7/8 minus 1 7/8 is counting back, taking away eighths, or finding the number of eighths between the two quantities. Iteration connects fraction operations to the whole number operation and explains why the denominator stays the same. 3/5 plus a half you can turn into 3/5 into 6/10 by multiplying the numerator and denominator by 2. And 1/2 you can go 5 and 10. So 2 times 5 is 10. 1 times 5 is 2. In the model I just talked about, 3/5 and 1/2, having a strong conceptual foundation of equivalency is critical for operations of fractions. Students who have a level of fluency is moving between a half, a 2/4, 4/8, 8/16, or 3/4, 6/8, or 12/16. Can adjust fractions as needed to add or subtract fractions. Common denominators are not required. Using reasoning strategies, students can see that many correct solutions are found without even finding a common denominator. Number lines can be used to solve addition and subtraction situations without finding a common denominator. You can also use fraction strips. Importantly, fluency requires choosing a strategy, so encourage students to decide on a strategy and continue to encourage reasoning strategies even after students learn to find a common denominator to add or subtract. Number 2, you can ask students to decide whether both answers could be right. Ask students to defend which answer is right and why the other is not right. Ask students to use the same model to show the solution. Apply the whole number operation rules. Tell stories with familiar context. Ask students to encourage a story using a familiar context to make sense of the operation. Do not find a common denominator, but apply standard algorithms. Ask students to model the problem on a number line or a fraction strip. Struggle to find a common denominator. Offer games and activities to reinforce multiplication. Mixed numbers. Subtract the smaller fraction from the larger. Include more mixed numbers throughout addition fraction units. Mixed numbers. Don't know what to do when one number is a whole number. Make these errors part of a public discussion, for example, using work examples with such errors. Foundational ideas of irretracing, counting, fractional parts, and partitioning are at the heart of understanding multiplication of fractions. Multiplication of fractions is really about scaling. If you scale something by a factor of 2, you are multiplying it by 2. If you are scaling by 1, you're multiplying by 1. The same amount is unchanged. Identity property of multiplication. Similarly, multiplying by a half means taking half of the original size, while multiplying by 1 1/2 means the original size is plus half the original size. The scaling concepts can enhance students' ability to decide whether their answers are reasonable. A good practice for students to begin multiplying fractions by a whole number, 6 times 1/8, 10 times 3/4, 1 times 1/3, and so on. You could also do it with mixed numbers too, like 3 times 2 and 1/3. For example, 7 times 3 means 7 groups of 3, so you have 3 plus 3 plus 3 plus 3 7 times. Same goes with 1/3. 7 times 1/3 is 7 groups of 1/3, so 1/3 plus 1/3 7 times, it's 7 and 1/3. See how it went from a whole number 7 down to 7 and 1/3, which is 2 and 1/3, so it shrunk in size. Here are some examples of tasks like 1/3 of 3/4, 1/3 times 3/4. So you show the original 3/4 and then you multiply it and show the answer is shaded as 1/4. Or you could use bread, 2/3 of 9/10. You can use it with fraction strips that are vertical, and you end up with 6/10. Or you can use paint, 2 1/2 times 4 1/5. You can have students draw it any way you want. In the figure below, you can use paper strips, and partitioning is an effective way to solve multiplication problems, especially when they require additional partitioning. Figure shows that paper is folded or partitioned into thirds first, then shaded to show 2/3. Next, the 2/3 must be partitioned or subdivided or to show fourths. Then the 3/4 is reshaded. Finally, the reshaded part is compared back to the whole. What fraction of the whole is 3/4 of 2/3? In the figure below, 3/5 times 3/4, you are finding 3/5 of 3/4. So you start with 3/4. To find fifths of 3/4, you draw 5 horizontal lines through 3/4, or all the way across the square, so that the whole is the same size partitions, and shade 3 of the 5. The overlap of the shaded illustration 3/5 of 3/4 of the original whole. Quilting is a good context because quilts are rectangles, and the individual rectangles or squares within the quilt are fractions of the whole quilt. 5/6 times 1/2. It's a good idea to use squares and partition it vertically and horizontally to model problems. You can ask yourself, how do you figure out what the unit of the fraction of the denominator was? Or how did you figure out the denominator would be 12ths? Is this a pattern that is true for other examples? Can you find a similar pattern for how the number of parts of the numerator is determined? You can continue to ask yourself to estimate how big you think the answer will be and why, and then to check the reasonable of the answer. A person might answer 5/6 times 1/2 to be slightly less than a half because 5/6 is close to a whole but not whole. Number 1, be sure to use visuals that are connected to procedures. Number 2, explicitly teach and practice each estimation strategy. 3, use visuals to illustrate, add context, or ask students to create context to fit the problem. Number 4, estimate. And 5, focus students' attention on situations quantitatively without focusing on actual numbers.